Okay, ready? Okay, give me a high five to start.
Boom!
Okay. Hey everybody, we're here at Adafruit for a special video. We've got awesome special guest, 2 engineers for the price of 1. With me is James McLurkin from Google. Welcome.
Hey.
Let's give it a handshake. Welcome to Adafruit.
It's wonderful being here.
This is, we had an engineer here last week and they said this was Club Med for engineers because it's just like there's all these machines and robots. And you do robot stuff all the time and electronics. What's your gig? Why are you here even?
Why am I here? So, all right. The top secret plan is to build things that build more engineers. So at Google, I'm working on a team, project AIY, artificial intelligence and you.
Oh, that's what it stands for.
So it's like DIY AI, do-it-yourself AI. But exactly.
Good branding there.
Exactly. Yeah. So our goal is to figure out how to get Google Intelligence out to everyone. And my top secret mission, as I said, is to build more engineers. And I want to really figure out the coolest, best, most awesome things to do with technology, get them in the hands of people, and then stand back and let amazing creative play happen.
Okay, let's like back up a little bit. So,
back up.
because you're an engineer and I'm an engineer, and the people in the audience may not know we both went to MIT.
We did.
And we both even lived in the same dorm.
Same dorm.
Which means we're like best friends already. And although a couple of years apart, we won't mention how many. So when people talk about AI and like that is other than Bitcoin, that's a big hot thing, right? AI, artificial intelligence, and you were at CSAIL, which is the AI lab, but like it's almost so popular. What actually is AI? Like, as you as an engineer, what do you think AI is?
So there's a bunch of answers to that question. First, I'll start with the Hollywood answer, right?
Okay.
AI is R2D2, C3PO. It's smart, emotional machines. It's humanoid in our space, or it's giant killer robots taking over the world, or it's machines that want to be more human. Frankenstein, Lieutenant Commander Data, etc. But these are all very sophisticated, very intelligent, very anthropomorphic sorts of AI, and a level of technology that we can't get to. We don't know how to go there.
So most people, when they think AI, what they actually don't mean is artificial intelligence. They mean like artificial humans.
Yes. Yeah.
Which is actually, I mean, we're not that intelligent.
Yeah.
Like before your first coffee, like it's kind of a mess.
It's a little rough.
So that's what Hollywood thinks. I think that it's like the sci-fi view, and I think, you know, we've had like the Golem from like, you know, medieval times. We have a history of imagining these humans that are not born, but this is a different type of technology.
So what AI is for real though is something that can be very useful. It's something that lets you given that we're looking at into this factory, right? But there are a bunch of things that are different here, right? There's something here that's different. This has some eyes, nose, mouth.
I mean, just
kind
visually.
Of thing. Visually.
Yeah.
There's some more over there that look a little different. Those are people. Yeah. And AI could look at this image and figure out, well, these things look like people. Let me classify these as people. Let me classify this other stuff as either other, or maybe in my database, I've got some other models where I can classify things to. So all I'm doing is looking at, for this example, an image and saying, here is something that I think is a person, here is something I think is not a person. A very simple classification problem. This is AI, and this is useful AI.
So when you're saying classification, you mean AI is basically computer-assisted, like a computer-assisted way of dividing something into categories.
That's one thing you can do with it.
And it's always vision, or is it other things?
Oh no! So the vision example is easy to understand. You know, dog, cat, person, sorts of things. AI can do speech recognition. It's a little harder because looking at an image, you can just look at the picture and match it to other pictures of dogs and know it's a dog. Speech, you have to understand more of the sentence, more structure, more intent. You need deeper intelligence to figure out speech.
Really?
Yeah.
You wouldn't think, because usually, like, we think of speech as simpler.
Audio is simpler than visual.
But it's not.
Not in this case.
Not AI. That's interesting. And then there's written.
Yep.
So, like, what's an example of written AI?
Your classic internet scrapers, crawlers that are going over, reading web pages, trying to figure out, maybe just reading your purchase, your shopping history. trying to figure out what to recommend to you for the upcoming holidays.
Oh, interesting. Okay, and then, so there's written, visual, audio. Is there any others that you can think of?
So that's the thing, right?
What about chess? Like people talk about AI as in like, oh, it's
Yeah.
like chess playing.
Yeah.
Is that also AI?
So it depends on how you want to do chess. Let's simplify chess to tic-tac-toe.
Okay.
So now maybe you don't need AI to
handle
do
that.
tic-tac-toe because you can just write down all the possible combinations of the board. So an AI to solve this would be a very simple AI indeed. Checkers is a little more complicated. Chess is even more complicated. And then Go is even more complicated. But AIs can
There's
solve
chutes
these
and
problems.
ladders in this.
Yeah, shooting ladders is somewhere
You know?
between Go and no.
So there's actually
it's
people
pretty
that
simple.
categorize how hard
games are.
And it's
there's
how
a
many
deep science there.
choices you have.
Yes.
And so with tic-tac-toe, you're seeing the computer, because tic-tac-toe is something everyone knows how
That's
to
right.
play. It actually, you can categorize every possible option, but then when you get to chess or Go, how does the computer, does it keep track of every possible chess configuration?
So for chess, you can, and this is what a lot of the chess algorithms the early ones did, where they would just search millions of combinations of moves going forward 20 moves to see X moves to see what was the best move to make at any time, given what could possibly happen in the future.
So that's why you need a fast computer. It would actually
Big, fast
It would
computer.
just chunk through every possibility.
So one of the mantras of AI in going back yesterdecade is AI is not search. Trying to understand that AI is something different. Intelligence is different. It's not just searching lots of combinations. And some games, for example, Go was a game that confounded search because there's so many combinations and so many games to play on Go that you can't just search it. So there was, it was hypothesized that computers would never beat Go masters because the game is just too hard. That was not a good prediction to make.
Bad prediction.
Because we've already done that.
And then, so it seems like there has been this. Okay, so I went to MIT and you were at MIT and there's the AI lab, and like there was kind of like, honestly, there's a little bit of a joke, right? That like the AI lab didn't actually do any AI. Like people were like, where is this AI?
Where's
right?
AI?
Like, and then the joke was like, oh, we had like fuzzy rice cookers. You remember that? Like
do.
everything was fuzzy logic, and they were like, people were thinking, is this AI? Is that AI? But and then there was this kind of this like mushy 90s, and like people were doing a little vision recognition, but it seemed like there wasn't a lot of progress. And then last 4 or 5 years, like boom, it's really exploded. What changed?
There are a bunch of things. So I'm not a historian of AI. Let's put that disclaimer out there. So what has changed from my point of view? The most important thing that's changed was a shift in the focus of what the goal was. The goal is no longer to build R2-D2 and C3PO in a human-like Android. The goal is the shift to let's solve an actual real-world problem. I'm in a factory. I have to tell this widget apart from this widget with a camera. Let's solve this limited image classification problem. Let's solve a problem where I've got to figure out what music you're going to want to listen to next. I have to figure out what TV show, what cat video do you want to see next on the internet. So these problems are far more local, far more focused, with data that's far more relevant to solving the problem at hand. Turns out these were still hard problems to solve. And that kind of machine intelligence with a solid mathematical and algorithmic underpinning, provable that I can prove that this is the best guess as to what I'm looking at based on the 10,000 things I'm comparing it to. This is the best guess, and I can give you the percentage of likelihood that it is this, and the confidence in my estimate.
Do you think that, there's a bit of a, like, oh, sorry, I like to get all these jokes out, but people say like, oh, engineers always have a technical solution in search of a problem. Do you think that was part of it, that we had 20 years of like, we had this, but we didn't know what we were solving?
Kind of. So stopping the grand notion of a general AI and zooming down, okay, let's focus on useful AI. Let's focus on techniques to solve real world problems.
Okay.
And then, so rephrasing it, that was good.
Yeah.
A bunch of other things happened too, right? Computers got faster. Our understanding of the probability and the statistics and the math got deeper. Our ability to, our sensors and our cameras got better.
Yeah.
Our ability to get around the world and move with robots got better. So there's a whole bunch of things happened at the same time.
There, I think that one of the things that you probably have to fight against is this. There is a Hollywood notion of whenever you build an AI, what happens in the movie? The AI goes rogue, and then it like picks up a gun and like shoots all the humans. I gotta ask, like, is this something that you think about? Is this something that you consider when working on AI?
My standard answer here is there's no reason to believe that anything we build is going to be, a sadistic, murdering, evil creature. Not unless we program it to do that. There's no.
Do you think humans have the capability of doing that? Ooh, tough.
Well, so, what is at the core of human nature, right? I do believe most people are good. I believe that most people, you satisfy their basic needs. You give them some food, somewhere to live, and some...
Cat videos.
Cat videos, something to build, because you have to build stuff if you're going to be useful. Then most people aren't going to go be mean.
Okay.
And I think that I can't imagine why, if we were able to build an artificially intelligent creature, a thing that was in the world, that had embodied intelligence, that could interact with the world, I see no reason to assume why I'd want immediately to then exterminate all people.
Yeah.
It seems not rational.
You think it's not? I mean, you're not making. Honestly, the things that you're making are these toys and these small devices, so they're not really capable of even moving.
I'm not. Yeah.
So,
and that being said, not only is it not rational, it's not proximate. It's not something that is going to happen in a very long time. I mean, the robots can't even tie shoes. Right? If you're going to take over the world, you can't trip over your shoelaces when you're doing it.
Yeah, and it's like the engineers actually build stuff are like, you got nothing to worry about. Like if you just turn 20 degrees, suddenly it's just like over. It freaks out, or like you put on a big hat, and it's like
back when I was in grad school, back at MIT, there was this big government-funded program to get robots to open the door. The Defense Department wanted to build a robot that could open the door.
But like with the turning knob and like
no, turning knob, well, way too hard. So they gave up on the turning knob and they went to the lever knob.
Okay, good.
Okay, but then turns out that pulling the door, that's too hard. So they went to then pushing the door. So a lever knob, push door.
Could they do it?
Yes.
Yay!
Yes. So once you got the problem, that's simple. But the solution then, if you've got a robot takeover at that point in time, lock the door.
Yeah. Or just use the round knobs. I mean, I can barely use those either.
Yeah.
So the kind of AI that you're working on. So yeah, we've seen this explosion of AI, and so I thought what's interesting is what you're doing with. We've got this really cute AIY project that was like super successful. And people really like it.
Yeah.
With the Raspberry Pi.
It's a lot of fun.
Yeah, it's got this button, and you can ask it questions. It's a
Thank
little
you for mentioning the button.
Well, the button is it's a pretty sweet button. I like how it's a candy-like friendly button. And then, we actually did a project last week where we customized it into like a little happy robot.
I love this.
Robot friend.
This is great.
Adabot, very cute. We have another button. I think what's interesting is there is this like divergence of opinion about AI. Either it's ruthless killer robots, or it's trivial, like silly, stupid stuff, right? Like, why have this trivial stuff? So I think what's interesting is you are kind of starting with these very basic things, like a voice assistant that like tells you the weather. But why go with that? Why are you like what are the things that you're doing, and why are you approaching them that way?
Well, let's back up a little bit. So there's not just giant killer robots and cat videos. There's all the stuff in between that you don't see. All the recommendations you get, your ability to use maps and get accurate directions that take into account for traffic and weather and other conditions, the ability of your camera to know where there's a face in the photo, and then set the exposure for that part of the photo. So there's AI everywhere that is doing its job, but its job is very small, very limited, and it does its job well, and your life just gets a little better. So that is where the bulk of it is, and that's where the bulk of it's going to go. The cat video stuff, the kind of cat, the example I give that's analogous to a cat video is a cat door.
Yeah.
So my cat comes to the cat door, and you want the cat door to open so she can come in. So I want to recognize my cat apart from a raccoon or a possum, whatever else may be outside, and ideally my cat from my neighbor's cat, so that I don't have a lot of cats in the house.
And a lot of people would be like, "Oh, this is silly. Just like open the door." But why do you think this is an important example?
That is an example of a real world problem. Somebody has a problem they need to solve. They need to get access control for their feline. And how do you get that in a programmatic way? Well, you can't do that any other way other than to recognize your feline from another one. And so this is a problem that you could say, okay, this is not a real problem. Or maybe you've got a recycle sorting line and you want to separate your recycles and your plastics into different bins. This is a real serious problem. Maybe you have a weather station and you want to have a better estimate of what the weather's going to be coming up based on historical data. I mean, there are a lot of problems, and the thing that we're trying to do with AIY projects is not tell you what your problem is. Have you find your problem, but give you the tools you need to then go solve it.
One thing I've seen that I think AI is going to be very useful for is these visual assistants, or these audio assistants and the face recognition. Like, you might think, oh, there's this cat door, and people are like, well, I don't have a cat, and like, I don't even let the cat outside because I'm an indoor cat type person. Right. But that same technology that is like open a door when it recognizes the face, we have a lot of people in the disabled community or people who are doing assistive technology, and these are actually very big problems. They have like, well, I want to open a door when a person is coming to the door and it's recognized and they're in a wheelchair, so they may not be able to easily get to the door handle, or they don't want to have to like call someone to open the door for them. So a lot of these things that sometimes get like denigrated or talked about as like, oh, these are silly problems for lazy people. It's like, no, they're actually problems that people have. Real serious problems. Just not you. Like, you don't have the problem, but people who can't open the door, or they can't get up and turn off their lights. So having something that does it by voice is handy.
I mean, the classic example there is the get me a beer robot.
Right. Classic robot.
So, I mean, but I have had multiple broken limbs over my life where getting a beer, I don't drink, but getting an iced tea would be a tough call. And having somebody to go get me an iced tea and bring it to the couch, that sounds pretty good when you've got on crutches and you've got screws in your knees and various things.
I think that's one interesting way to look at it, is like, okay, not just how would it be good for my cat, but how would it be good for, like, there's other situations where that might be useful. Actually, what's funny is we're doing some projects now with 4-H, which is 6 million kids in the U.S. are in 4-H, and they do a lot of agriculture projects. And so this would be a great project for somebody's chicken coop. So it would recognize if a chicken was trying to get into the coop, it would open the door. But then if it was like a fox or a raccoon, it wouldn't open the door.
Or are the tomatoes ripe? Or are they not ripe?
Right.
Is it time to harvest this crop or not crop? Is the soil over here wet or not wet? So you could build your little soil measuring box and drop it in your fields and get data, and ideally have that box make a decision based on the data it's got to turn on water or not turn on water. And so, we'd like to build things that people don't have to have a big giant computer in the house with the 10 monitor control station. Make the decision locally if you can. If you have your AI that is small enough and cheap enough and easy enough for you to use, and you can put it on your local embedded Adafruit part number 859 sprinkler controller. You've got one of those, right?
Oh, yes. It's number 2536.
Exactly. Yeah. Then you could turn your sprinklers on the right time, the right location to get your crops to go.
Which could actually be useful if you're in California and there's like a drought alert or something. Well, now they don't have one, but when a couple of years ago when they did, and it was, you couldn't turn on your water before this time, and maybe that's when you would actually want to have a smart system that helps you, conserve a resource. We have at home a thermostat that also is smart. It tries to detect when we're home and like how often we're home. Right. Actually, it's funny. I actually have a toilet seat that's smart. It's like a Japanese style one, and it knows when we go, and so it heats up the seat because we kind of get up at the same time. Okay,
but it's nice, isn't it?
Dude,
it's nice,
it really
isn't it?
changes your day when you have a warm seat and you're like, okay, I'm ready to take on the day and do some engineering.
So I'm covered with scratches on my hands and arms because I've been doing a lot of home remodeling. We just put heated floors in our bathroom for exactly the same kind of niceness. You walk in there, Seattle, it gets cold in the winter. You walk in there in the winter, and it's like, ooh.
That is nice, fancy. All right, I like a fancy house. And so are you going to add AI to your house? Do you think like home control is something that...
I'm dabbling in it, but there's a user interface gap between the AI that I'd like to deal with and the AI that my aunts, uncles, cousins, and mother would want to deal with. My wife is very patient. Lights come on, they go off sometimes. Things don't work quite the way I intend them to work.
Firmware upgrade for your light bulb, you know.
Yes, but when family comes, the stuff needs to be ready to go. So I tread lightly on that at home.
I think there is. I think that is something that as it's interesting how AI it brings together almost every discipline of engineering, and of course the UI, and of course the empathy for the user. So how to make it so it's smart, but also able to be dumb. Like I have smart lights in our place. We have to test this stuff.
You need tech. Tech is good.
So we can turn off the lights very quickly into the entire house. And I like how you can still use a light switch.
Of course.
If you're like where am I? Okay, I know the light switch is here. You can flick it.
So
and turn it on.
the voice interface. So that was our first kit. Was the voice kit, and we started with that. This one right here.
Yeah. So what? How did you do this, and what did you do here?
Okay.
What is this?
So the first thing to say about this is that it's very, very simple.
Okay.
So if we get inside here,
Okay.
it is a simple circuit board.
Okay. Raspberry Pi.
Yep.
Hat.
Yep.
Button.
And on there is an audio amplifier, and servo connectors.
Yeah. Microphones.
Microphone board,
Yeah.
and connectors for buttons and the speaker.
Yes.
And that's it.
Okay.
That's it. So this one takes all the data that you say to it, sends it up to the cloud. The cloud then, the AI runs in the cloud, figures out what you're saying, and then sends you back the text of what it thinks you said, and also sends back, if you use the assistant, sends back the assistant verbal response in an audio file.
Okay.
So if you want to play the response, how tall is the Eiffel Tower, it'll tell you how tall the Eiffel Tower is. However, if you just want to control your trains, so in the video that I shot for our launch, I had my little model trains on the table, and I said trains fast, and the trains went fast, trains slow. So I could just.
You're using it then as a voice recognition system.
That's right.
Okay.
So if I want to turn my trains on and off, if I want to lower the blinds, if I want to do anything I want to do in my home or in my projects or anything I'm building, I can now use voice to do that.
And is that, so I know that is it based on the same technology as this Google Home Assistant? So whatever this, and so we were saying earlier actually that voice is harder than video.
Yes.
So for this one, you have to have an internet connection and always sends it up to the servers. And does that happen on this one too?
Yeah, it does.
Okay, so all voice stuff is always updated.
For now.
For now. Until we get better at it. And I think all voice recognition systems that are any good must do that.
You can do some local stuff. So for this, the hot Google, the hot word, that's local. So it's not listening all the time. It only listens. It only listens when you ask it to. But then the request you send goes up, and then often the answer for that request is in the cloud as well. So fine. Getting that computation local is a big push for what we're doing. There are privacy reasons or security reasons. There's all kinds of reasons why you'd want to keep your data on your device, especially if your data is images. So the Vision Kit, which is over here. Vision Kit. This is number 2.
This is unreleased.
Unreleased.
This is the first one.
It's very, very close.
We put it together and it was like amazing. It just had that like fresh scent of unreleased hardware, which is always good and exciting to put together. So we put this together, and this has a Raspberry Pi Zero W.
Yes. So very simple, low-powered computer.
Very low power.
Yep.
So is it Pi 3 required for this, or just simpler?
It was simpler. Okay. So we started with the Pi 3 because it was an easy form factor. The board is bigger. We didn't have to work very hard. We switched to the Pi Zero W for this one because we took the processing off of the Pi Zero W.
Okay.
And the Pi Zero W by itself can't do the kind of speech processing, vision processing we want to do.
So this one has this other board, and there's also a Pi camera.
There's a Pi camera, which is right here.
Yeah.
Right
and
there.
This wonderful button.
This gorgeous RGB button.
This gorgeous button. Nice button. Okay, and then this camera board, it doesn't have like that. The other one had just the microphone amplifier, so it's just audio like amplification.
Right. And that audio went right to the Pi.
Okay. And then what is happening on this?
On this one, there's a video coprocessor in between the camera and the Pi.
Okay.
It's a Movidius chip. It's the name of the company, a company of Intel, and it's specially designed. It's a video processing unit. So especially designed to process video. So you've got your camera images, they come in, and the chip crunches on them, and it can crunch quite fast. It can do 30 frames a second.
Pretty good.
Basically, it's real time. And then it tells you what it thinks it saw based on the neural network model you gave it. Okay, I just said a bunch of words. Neural network model, what's all this mean?
So you have to tell it ahead of time what it is you're looking for.
You start with a whole bunch of images of things you want to find.
Okay, bicycles.
Yeah.
So you show tons of photos of bicycles.
Pick all your bicycle photos, and then pick all of your rabbit photos, and all of your elephant photos, all of your banana photos.
I have to keep these apart.
Your hot dog, not hot dog.
Yeah.
So all the things you want to detect, lots of photos, and then you label them. Say, here are all the things I want to detect, and here's what they look like. And you say, learn all this stuff, and separate hot dogs from elephants from cats. And then the neural network model will then learn the different features and the different distinctions that separate these classes of items.
Okay, well here I gotta ask you the tough question of how does it do that? Like what's going on? Like when we talk about a model, this is kind of where even for me it gets a little fuzzy. What is this model? Like I understand that you train it with images, but then how does it know what a bicycle is? Does it say like, oh, there's two wheels and then there's these like triangles?
So it doesn't have that kind of semantic understanding of the parts of a bicycle. That's kind of how we started, in fact. We started by, and there's a lot of research going in that direction, trying to understand, is that a chair? Well, chairs look different. You can sit on them. There's a bench in the subway. There's a chair on a bus. There's a chair in an airplane.
A
bar stool that has a back, that has arms.
Those big papasan chairs? Totally, that confused me.
So there's this notion of here's what this thing does, therefore it's a chair. So you have to infer what the item is based on the function it can perform. This is hard. Bicycle.
I mean, like this, like I have philosophies about this.
This is hard. So it turns out if you just take images and look for lines and edges and relative proportions of here's lines here, and here are dark spots and light spots and simple features. Simple features in the image that if you saw the list of what the computer was looking at, it wouldn't immediately to you mean Dalmatian. But to the computer, all these different features together, so I'm using more words.
No, but it's like it figures out based on visual elements. It doesn't recognize it as an object.
No.
It just recognizes it as its cues, its features.
Correct. And these features can be very, very small, very subtle things that you're not paying attention to, things that you wouldn't even notice about the object.
Yeah.
So the computer figures these out and then clusters them all together. So this set of features means Dalmatian. This set of features means Mastiff. This set of features means Terrier. And then you give it an image. It pulls out the features, throws away the image, and says, okay, these features are here.
Match them.
This part in the image is the closest match to this set right here. Therefore, most likely this thing here is a Terrier. And I can give you 80% likelihood because 80% of the features I see here match 80% of the features I see here. I can give you confidence that's not these other things because it is, very unlike this. There's a separator between here and here.
And then, does the vision chip? So you got the neural chip inside, and you give it models, and then can I create my own models, or is it like, oh, here's like 50 models that comes with it?
So right now we have 3 models ready to go. One of them we ship with called Joy, which will detect a face. And I emphasize detect as opposed to recognize. It can't tell your face apart from my face.
Okay.
But it can say, oh, look, there's a face.
Face.
So if there's a face, the light comes on. And if the face is happy, then the light changes the color to indicate joy.
Okay.
So the feature that it's looking for, it features, what does a smile mean? Right. Well, a smile means there's an angle here, there's an angle here.
There's some like
between
white
angle,
things in the middle,
there's
maybe.
Some thing. Yeah. There's features that indicate that here's a face, and on this face, the expression of this face, the features here match a smile. I don't know who it is. I can't tell you which way it's facing. I can't tell you. There's a whole bunch of stuff I don't know about this face. All I know is that I think there's a face here, and I think that this face is smiling or frowning, or actually it does know if you're looking at it or not. Actually, that's one of the things in the text.
Eyes forward.
Right.
Okay.
And this is important if you want to take a picture. If you want to build a selfie bot, then you want to know, are people looking at me? If so, take a picture.
Okay, we'll upgrade because we have the Sophie selfie bot. Maybe we'll upgrade it so you actually have to smile at it.
There we go.
And it runs on a Raspberry Pi, so it's
There we
very
go.
convenient. Okay, so we've got a couple models that it comes with, and I think this kind of leads into like the more intense question that we mentioned before we started, which is you have to train the AI with data.
Right.
You have to tell it, this is face, this is Dalmatian, this is banana.
Right.
And like we were talking about how this, because I think, there's this, we talked earlier, like, okay, there's AIs that are the evil AIs or good AIs, but really there's only what the AI is programmed to do.
That's right.
And when people talk about like, oh, the AI is smart, well, it's smart because of that training data, right? Whatever you feed it, just like humans, you feed it junk food, you get junk food. If you give it good food, it grows up strong and healthy and joyful. Yes. And there's the ethical obligation that we have to train our AIs.
Yeah, this is hard. With
good data. So how are we going to do that?
So you're getting to the name here is fairness in AI.
Yeah.
And how do you make sure your AI is fair? And how do you make sure the data you're giving it is unbiased? So if you give the AI biased data, and you may do it through no evil intention of yours at all. The data you had, here's the data you got. Maybe all your Dalmatians happen to be boy Dalmatians because you didn't have any pictures of the girl Dalmatians somehow. So when you learn Dalmatians, maybe there are differences between male and female Dalmatians that your AI now can't tell them apart very well because all the data you gave it was male Dalmatians.
Yeah.
So understanding where that bias is in your data and making sure your data is fair so when you train the AI is fair is very hard. The internet, if you search for whatever term you search for, what result you're getting is images that people have labeled with, here's a tree. But if somebody labels a tree and they aim it at a pecan, or they aim it at, because it's a pecan tree, and all they show you is the pecan in the tree, but the word tree is labeled under the image, the computer thinks that this is a picture of a tree. It's a tree is a round thing about this big, that's brown. That's an honest mistake.
Because again, it doesn't know semantic idea of a tree or a bicycle. It just knows, I got these images. And I think that's interesting. I think especially, and that there is, we're engineers, but historically when there was a photo of an engineer,
it didn't look like either of us.
It looked like some person in a white lab coat. And they were probably designing a car. It was like a German engineer, right? Designed this car, and it's like fancy. Yeah. And it was a really beautiful car, but I think it didn't necessarily have a good representation of engineers. No. So I think this is something that we think about. Well, I think about it because the representation, that what is an engineer semantically? We know it isn't by definition a 35-year-old white male who lives in San Francisco, but right now it kind of is becoming. That's
what, if you look at the magazine covers, right? If you're a data set of engineers, magazine covers.
Yeah.
Well, the first thing you assume is that there's only one, and his name is Elon.
Like Mark Zuckerberg, right?
right, yeah, exactly.
And you have to wear a hoodie, which I have, so I would actually probably classify quite well.
That's right. Yeah, I left my hoodie over there.
But you're wearing a black T-shirt.
That counts.
Yes.
I'm halfway there.
Yeah, it's like 20%.
So that's a fantastic example of things that is not fair, right? Magazine covers are not fair, right? You've been on Wired and Make.
Yeah, and we fought for it.
Yeah.
I was the first female engineer on Wired, which is kind of awesome, but also kind of sad in a sense.
2020. What year is that?
It was like at least 15 years into the magazine, and I think that other people who were readers told the editorial staff, they said, we want to see more representation.
I should go see. Has there been a black engineer on the cover of Wired? I don't remember any.
Yes, but embarrassingly, I cannot remember who it was.
I should go find that out.
Okay, we'll find out right afterwards. I wasn't prepared for that. But how do you think? Okay, so we were talking about representation, fairness. And fairness is something that computers. When computers talk about fairness, they really just think 50% versus 50%. And if it's just a little bit more, that's what pushes it. I'm saying, if you have data and like you said, it's recognizing an object, it's giving you a confidence.
Yep.
That confidence is a mathematical confidence, not a human confidence.
So we can take. Some people get great comfort. I've got mathematical numbers, I've got mathematical confidence, and my answer is fair. But until you are sure your data is fair, then anything your algorithm does, your algorithm may truly be unbiased. Your algorithm may truly be algorithmic. It looks at the data, it does what it says it's going to do. It does not inject any opinions, any history, any bad experiences, anything its parents told it. It just runs the code. But if the data is not fair, then the algorithm cannot produce fair answers.
I think something that could be interesting, because a lot of times, I think transparency does help with this. I think if people are using an AI, it would be really cool if you could then, and it's like, okay, let's say it's a face recognition AI or like an engineer recognition AI. It would be cool if there was some way to go back to that model set that it was used for training, like not know the neural network, but maybe see, here are the photos that we used to train it.
So this is why getting AI out to people is so critical. Keeping it all locked up behind doors and temples of technology, we're not going to find the errors. We're not going to find all the problems. When it's out in the wild and people are using it and trying to get it to do what they want to do, they bring it home to their family. They want to recognize the faces of their family, all shades of brown, all shades of white, all shades of whatever they've got. If the algorithm isn't doing that properly, and then they fix it, and then they upload it, the world now just got a little better. So the ability to, I'm getting to your question, how to train models, the ability to take a model, modify it, and then repost it, and then share that is critical. And it's something that we're working on very hard right now to build a model library where you can go get them and train them and tweak them to solve your problem. But fairness, if you have a bunch of people sitting in San Francisco solving a problem for people somewhere else, and they've never met them, never seen them, don't know what the actual problem is, the likelihood that they're going to get it right is not high.
It's like because your only experiences are, their idea of a bicycle may be very different than what somebody in Tokyo thinks
and
is a bicycle.
You can look at pictures, you can read the internet, you can look at the presentations, you can do video conference calls, but until it's actually in that environment trying to solve the problem in that location, you're missing the key data, the key interactions that make that thing work.
And do you think that this is one of the biggest problems, not problems as in like to solve, but just challenges?
It's on the list of problems. So having more people with their hands on the technology who can use it will only make it better. They will find ways to use it that we haven't thought of. They will find problems solved that we haven't thought of. They will share their results in ways that for things that we wouldn't have done already. And the world will only get better. And then again, it goes back to my top secret mission, which is to build more engineers. Right? We've got more engineers now working on problems that are local and relevant to them, and solving them using our tools, solving them to make their world better. And by doing that, the whole world gets better.
We were talking before you even showed up here about what is an engineer.
Right.
And so now I got to ask, because you said you want to make more engineers. Is that your personal goal, or is that your group?
It's my personal goal.
Okay,
but I am slowly, spreading that around.
Okay, well, everybody watching, you should go and make more engineers.
More engineers.
So what is an engineer to you?
All right, so there's this.
I can tell you're ready. You're like,
yeah, I'm ready to go on this one. So no, cause we talked about this earlier, right? And I wrote down at least 4 classifications that are lines we can try to put in between: engineer, maker, artist, scientist. And you could argue I've been one of some of these, and you have been one of some of these at different times, different periods. Engineers, fundamentally, they build stuff, but they build things that are built to specifications with blueprints and plans, almost never by themselves, almost always in large teams, packs, herds of engineers.
Googles.
Googles, exactly. We decided, so the internal code name for our team, we call it the Space Pandas.
Space Pandas.
Space Pandas.
Okay.
And we decided, and the multitude, I couldn't find a good multitude. We decided that we are a ruckus of space pandas.
Ruckus of
ruckus.
Space. Oh, that's good. All right, so your engineers are working in teams.
Yeah,
and that's what makes them engineers.
So there's the notion of there's a product and a problem and a spec. So there's a bunch of structure on this. And this, in my mind, when I'm engineering, I'm living in a world where there's a bunch of people around me. We're trying to solve a problem together. There's a bunch of structure. There's a bunch of technical documents and math and ultimately even legal stuff to make sure that it's the right thing and we're not getting in trouble for it. We're not going to hurt anybody with it. That's engineering, and it's slow and it's steady. When we can ship something, when we get to a product, there's this launch party. It's this big thing, but there's this ramp up, and then the launch, and then you ramp up again. So it's a very structured, kind of heavy process. When I go home and it's late at night, and I'm trying to, build a model train that control my voice, now I put my maker hat on. Now I break out the hot glue gun and the scroll saw, and I use CAD to help me think and to design stuff, but if I can figure out how to do it with a drill in my hand.
So that's making to you.
I put that in my making category.
And do you think that's more fun?
It's all fun.
Okay.
Right? Because making, I can build one artisanal, bespoke, handcrafted item, right?
Yeah.
I can't build 100,000 of something, right? In order to do that, I have to put my engineering hat back on. I got to work through a factory manufacturing plan. I've got to get on a plane to China. There's a bunch of stuff I got to do to have that kind of 100,000 unit impact. If I want to build one artisanal model train set, okay, I can do that downstairs in my basement.
Okay, that's cool. So you kind of move between the worlds.
You have to. I mean, you must do this.
No, I think I do, and I think a lot of it is, for me, I think of makers as people who are solving individual localized problems, and then engineers are they're taking one product and trying to make it all kind of fit together. Because again, you have to make 100,000. So you're like,
right.
well, how many people's problems can I solve with this one thing? And you do have to just make decisions.
There's trade-offs.
And I think with makers, I think they don't have to make as many decisions. They don't make as many decisions because they're like, well, let's just get this working.
Yeah.
And I think there's something joyful about that, which is why I like being in the maker community.
Right.
So why did you decide to release this technology, the AIY technology, to the maker community?
So I try to imagine always, what does the 15-year-old James want today?
Well, what does this fit? Is he still inside there?
Oh yeah, he's there.
He wants ice cream for dinner.
in my presentations, I have a picture of my first robot, which was a little wheeled. It was a Sears radio-controlled car that I took out the electronics and put in a relay to control noise because I didn't understand how bipolar transistors worked. I was in high school. It was very complicated stuff. But I put a water gun on the front. And 15-year-old James would love for a way to aim that water gun at somebody. So in order to make that water gun work, I had to ask my mother to stand very, very still. Okay. And then I could drive the robot and I could shoot her at an ankle. But boy, wouldn't it be great if I had some kind of tracking on that water gun to aim that thing better.
So it's funny. It's like this is like your rosebud. Like you're just creating a solution. No, I mean, like honestly, a lot of the projects I do are
with the
like
assumptions that 15-year-old, with the assumption, okay, they're making some assumptions, right? The 15-year-old engineer, that person, that there's an engineer inside of all of us that wants to come out, and if there's the right kit, toy, plaything, project in front of him, her, then she'll see it and say, oh yes, little brother, water gun, I can do this.
Okay, so for all the people who are watching, and there's going to be a lot of people watching, because we're going to put this on the internet, what do you recommend that they do though if they pick up the AIY kit, either the video kit or the audio kit? What would you tell them to get them excited about the project they're going to build? Like get them like thinking about what they want to do. So, they're like, okay, I got this voice thing. What do I do with it?
What do I do with it?
What do I do with it?
See, I've been trying to answer that question in general, and every time I do that, I kind of get into trouble because I don't know what everyone would do with it, right? I would never have built this beautiful thing, right? The notion that what we need is a bespoke, artisanal, wood-carved...
Aimbot head.
How did you do this, in fact?
This is 3D printed wood filament.
Yeah, right. I didn't know that. I didn't even know that was a thing. And one of my colleagues at Google was now going to roll over and smack me when I get home because, of course, I should understand 3D printed wood filament. But right. So I have stopped trying to imagine what everyone else is going to do, and that gives you also the ability to be joyously surprised. Like when I come and see things like this, I was like, ooh, that's really cool. I wouldn't have thought of that. So, but I can think about what I want to do. So this is a cop-out answer, right? What do I want to do? I want to control my model trains.
Okay.
I want to make my lights go on and off.
So home automation, model trains.
I want to build ridiculous. I'm an engineer now, right? Every now and then you need Nerf blasters if you're going to be an engineer, right? So
you want to build toys for your kid?
Yeah.
That would be cool.
Yeah, kid toys.
Kid toys.
There's no reason why we have to have plastic bricks that aren't smart, right? Let's have some smart construction toys. Let's have some. Why can't the Christmas tree talk back to you, right? Why can't the elf on the shelf look around and move from shelf to shelf? There's, I mean, it just goes on and on and on.
So like adding wonder to your world by
it's just
by
fun.
making it interactive, by making it know things, and maybe make these toys, and these toys will maybe train the next engineers.
So now we're getting to this maker artist overlap, right?
Yeah.
Is on the list. We're working the list here. What is art? My understanding of what art is there is something inside of you that just has got to come out, and it is influenced by the world around you, it's influenced by people around you, but it's a very generative process where I see this thing in my head and I've got to, it has to exist in the real world. Or I have this idea that I need to test. I have this idea that I need to put into the world and see what happens with it, see how it goes. So it's that kind of experimental kind of art. So at least that's how art feels to me, where I see something. Okay, here's a secret.
Wait, you're not telling the internet, are you? What's the secret?
So one of the things, I kid you not, that motivated me to go into multi-robot systems was Fraggle Rock. And if you go back to Fraggle Rock and look at the doozers,
yeah.
They're building all these little moving animatronic things for building stuff. I was like, man, wouldn't it be great to build lots of little robots? I mean, I'm in middle school, right? So this notion of I'm going to grow up and be a professor, this was not what I'm thinking about, right? But wouldn't it be great to have a bunch of little things that can build stuff? You know, 30 years later, that's basically what I'm doing.
I think you're right that art is something that you have inside of you,
Yes.
and you're like, you have to get it out. You have, it's like a sneeze, right?
Yes.
It's gonna come
Very
out
good.
one way or the other, and. But whatever you have around, you know, you're like, I have this idea and you want to create it, whether it's be this smart train set or this Lego that can recognize your face,
Right.
or the doll that says, you know, good morning when it sees you wake up. And if you're interested in is like, how can create these tools that people will use to get the art that is this interactive
That's right.
electronics out. So you're actually making art supplies.
Yes.
Okay.
We should change our name.
You should-
I like
the
that.
art
I
sup-
like that.
Art supply.
Art intelligence for
your
you.
suit.
AIY.
Yeah.
Art intelligence for you.
Art
We can
intelligence
keep the
and
same
artificial.
logo.
Yeah, artificial is a little bit like artificial.
just shorten that.
Yeah.
Art.
Okay.
That's-
Well,
lot
it
of
was
stuff.
awesome to talk to you.
Likewise.
And I think we covered kind of everything from the
Yeah.
brain, philosophy, to ethics,
Yep.
to robots. And you brought these awesome demos. We'll take some close-up videos
Yeah.
of them. And thank you so much, James, for
Yay.
showing up and hanging out
Been a
with
pleasure.
us here at Adafruit Club Med for engineers. And we're going to take some B-roll and we'll show off the
All right.
this awesome robot that moves around, recognizes
Excellent.
faces. And of course, sign up for the AIY video kit. This is on pre-order right now, right?
It's on pre-order.
Pre-order, but we'll be shipping soon.
Mm-hmm.
And then the audio version, the AIY
Buy
Voice
as many
kit.
as you want right now.
You can buy as many as you want right now. They are
Right.
available kind of almost everywhere, online, in stores.
We're
et cetera.
trying.
Build your own. And what's cool is no soldering is required. So it's a really good.
So that
Really good.
on the list of things that we have to learn as a company, I know we're trying to stop right now. However,
No.
we have to learn what is the maker hardware style guide.
Yeah.
We got a lot of that from you, by the way. Thank you.
Okay.
How should things look? How should they go together? What connector should we use? Should soldering be required for some of these things? And,
Tough questions.
And you know, there's cost, there's efficiency, right? If you want to solder connectors down, you have to pay for that. And what we kept on coming back to is we all want to be able to show up to a middle school with a big box and just dump it out and say, all right, we're going to build some stuff today and it's going to be smart stuff. We have 2 hours, let's go. And if you have to spend an hour and a half soldering, you're not getting anything built. So that has driven us to say, okay, the connectors for you know, the basic kit and for the first expansion, let's have these connectors already soldered on the board, for example.
I think that's good. That was good engineering design ideas, practice.
We try.
Cost, usability.
We try.
It's tough.
That's how it goes.
And we're going to make more engineers, but the cost usability
Always hard.
that's very hard. Okay.
All right,
well,
let's
thank you
try again.
Again. Now we're really done. You can tell us
Just
engineer
episode.
because we just can't stop.
I know.
We're just like just engineering all the time. All right. Thank you for watching, everybody. And
Bye.
of course, check out the AIY stuff from Google. And James, you have a website maybe you can plug for for all this stuff? Is there somewhere they can go to read more about this?
Well, just Google AIY projects. And
Oh,
you'll
that's
find it.
right. They got a Google search engine. Just go there.
Yeah, no, it's
And
not hard.
check out the AIY projects, and well, maybe there'll be a third kit coming out soon. Can't imagine all
Maybe.
the- Maybe.
Maybe.
All right. See you later. Thanks for watching.
This is an object classifier. For some objects, it does a great job. 99% Granny Smith Apple. Computer keyboard, 44%. All these data, 1,000 objects are loaded. These are all loaded in the memory of the device. There's no internet here. Some objects it struggles with. But this is one of the important things about artificial intelligence. It's not perfect all the time. Cleaver, meat cleaver, fountain pen, ballpoint pen. So the angle changed that. This particular pen, as attractive as it is with this MIT logo on it, it doesn't really know what it is. It thinks it's a bobsled. So these kinds of errors that the software gives are going to be what users need to work with and to understand that artificial intelligence is just as limited as any other technology that they're working with.